Hey, hi, I'm Andrew Moore, work at Uber, and I'm going to be talking about our experience with observability with Spire at the scale that we're operating at. So I'm going to be starting with just an overview of what the telemetry implementation looks like today in the code base, a description of the scale we're operating at, some nice like universal basics for monitoring and alerting, and then more specifics about like agent observability, server observability, and then end on what you all can do today to kind of fine tune things in the code base of it. So as far as the telemetry implementation, the two big things to note is that it is all centralized in package common telemetry. And in there are wrappers for like specific processes and APIs within Spire. So a big thing there is don't write your metrics in place. Initially, when Uber joined on to using Spire, metrics were pretty much all written in place. That was bad times. Don't do that. Centralize it all to just making some wrapper in these telemetry packages for the API or the call or whatever that you need telemetry on. Another big thing is that there's this nice call counter struct. And by just using that, you automatically get for free just a count, you get the error type if there was an error, and you get latency. So an example there on the right is saying, let's say this were like server code in the top half, just importing the telemetry package, and then there's the actual function definition of creating a registration entry. And first thing you do is just call the telemetry package to say, hey, start like recording metrics and defer the call counter being done. The actual wrapper definition is just in the telemetry package there, and it just passes on the metrics object you gave it, and then you hand it additional name constants for what you want the metric name to be. What this all results in at the end there, if you were like fetching for these metrics for alerts or for a graph, then you see that the name winds up here as like registration API entry create and your like status error code. And that matches up with the fact that we're passing into done an error, which gets processed for free. And then passing in that matches up with these constants here, the registration API entry create, all just getting appended together. I'm not going to go into every single metric that is available. There is a lot of them, but this is kind of a high-level overview. Pretty much all APIs are covered. There is a metric for them, and they are nice and organized in that telemetry package. So you should be able to find what you need, find the wrapper for it, look in the code for where that is, and you're done. The syncs that are supported today are M3, Prometheus, dog statsd, and statsd. There's documentation for configuration on that. And a really nice thing is that we are flexible here in that you are able to configure multiple syncs at once. So if you are in a state where actually we were for a while, migrating from one sync to another, you get to have both running for a time and be able to compare. One, make sure the migration actually works, and two, work out any kind of nitpicky things that might arise just from the fact that you're using a different kind of metric sync. As for the scale that we're operating at, we are deployed fleet-wide. We have several independent data centers, and every data center has less than 10 Spire servers. There are 20 to 40,000 hosts per data center. Each one has a dedicated Spire agent on it. And every data center every day performs millions of X509 signings. In total, we have over 300 services at Uber onboarded, which represents less than 10% of all the services in the company, with our goal being we are going to onboard everyone. Finally, while there are foundational teams regarding like bare metal and host health, generally teams kind of own their own host groups. So they can get support from foundational teams, but overall, if there's an issue with a specific host, and this will come up later, you would contact that team, not necessarily a foundational bare metal team. So some universal basics for observability is you pretty much always want to be looking at success and error rate. You want to be looking at latency. You want to be alerting down to like specific APIs that you care about, not just some like general alert for anything related to registration. You want like registration, create, and delete as separate things, for instance. And finally, always be logging things so you can have details later when something does go horribly wrong. Going into specifics for agent observability, things we notice is that cardinality and the number of metrics being emitted are super critical. Very high cardinality and frequency of emission can actually like start crippling your observability infrastructure and also make it more difficult to query for the data for your alerts or for your graphs. The queries might time out, or they might just take far too long for the graph to be usable. The contributing doc covers some nice standards on like pitfalls to avoid when you are defining out your metrics. If you ever do want to introduce new metrics or new tags to existing metrics, the thing to always keep in mind here is that metrics are for the general what is going wrong in the world, and then logs are for how is it going wrong, to provide those details. So if you do want to add more details to a metric, think about what is the increase in cardinality here, because at very large scale, that does start hurting observability infrastructure. Some things that we have encountered in the past related to these pitfalls, and if you do ever see any of these in the code base, put out a PR to fix it right away, is metrics that have, say, a SPIFFE ID as a tag value. That's ridiculously high cardinality. Counts or other somewhat arbitrary numbers as a label or a tag value. Dynamic label appearance, as in for like a specific metric name, sometimes a label appears, sometimes it does not, and that actually can break certain metric syncs. For instance, Prometheus has a big problem when that sort of thing happens. Also, I actually just updated the contributing doc yesterday, is having metrics inside of loops is also bad. Generally, if you're trying to aggregate some count for a metric, aggregate that count as an integer within the loop, and then at the end of that, just do one nice emission with the total counts. Don't emit a single metric for every single iteration. It could be dozens, hundreds, thousands. That's a lot of data when you just want the total aggregate. Also, when you are querying, make sure that you are very specific for your querying for tags or labels. This makes sure that you decrease your fetch time so that you can get proper graphs and proper alerts going. One big thing that I brought up before is that host ownership is kind of varied across all the host groups. And probably you, as the person that owns SPIRE at your company, don't also own host health fleetwide. There is, at scale, pretty much always a fire happening. And if you alert on any one agent problem at this scale, you are going to go absolutely crazy. So you need to make sure you're deferring like single host and host alerting to other systems, preferably creating runbooks so that host owners can actually triage a SPIRE agent themselves, find out what's going wrong with the host in general before they decide it's SPIRE agent's fault, and so on. Some nice like kind of workarounds or solutions in case you are encountering too many metric points being emitted is one, the easiest thing of just ask for a capacity increase. If that's possible, great. Other possibilities are to aggregate metrics earlier on in production. So that means you're going to lose some time granularity, or you might lose some tags or labels, but at least then you do get some data versus getting none. Another thing that's going to come up later is also having server alerts that indicate your agent's health, kind of like black box alerting against the agents. Moving on to server observability, one very important thing to keep in mind is there are metrics for the SPIRE server APIs and metrics for the SPIRE server's calls to the database. So that can help you very quickly narrow down when a problem is happening. And so in this case, we have, say, on the SPIRE server API, the fetch x509 success rate is just plummeting. what's going on? So just look to the middle and the right graphs, and those are the database metrics. And you see, oh, okay, so node fetch against the database and registration list against the database, those are both failing. So we've already skipped over the entire Spire server module and know that this is a problem either connecting to the database or the database itself is lagging. Really narrow down specifically, like, where should we be looking for this issue? Going back to what I mentioned about like kind of black box alerting against the Spire agent, is that for Spire server alerts, you shouldn't just be alerting on the standard stuff of like high error rate or high latency. Having kind of at scale an absence of errors or lower than normal latency is actually a little bit suspicious. So one example here that we've had is briefly fetch XO509 latencies started timing out, and then they went down to below the original baseline for latency, which normally might look like, well, that's actually kind of nice. Maybe we changed something for the better. Well, not quite, because agents just stopped calling Spire server. So that's really bad. So you should be making kind of metrics on Spire or alerts on Spire server for, say, expecting a minimum level of load or alerting on a sudden drop in load, because you can't necessarily count on having agents deployed fleet-wide. You can't necessarily count on getting alerts from the agents themselves. So you got to have this kind of aggregate stuff on Spire side, on the server side. Finally, just ending with things that everyone can contribute to the project to improve, is it'd be nice if we had some central documentation on what all the metrics are in the code base. They are at least all centralized in that telemetry package now, but having some sort of guarantees and documentation about it would make things much more clear, I think, for a lot of users, so they don't have to dig into the code to see it. Having more complete unit testing of all metrics. Not all modules unit test their metrics, so we got to like start increasing that testing there to make sure we don't suddenly lose them and not realize it. Introducing benchmarking to like key operations on Spire server and Spire agent. Right now, I just made some benchmarking a few months ago, I believe, against the telemetry package itself, but it'd be nice beyond that to have further benchmarking so we can see, like, as the code base continues growing, what are the enhancements that were made to processing time or to memory accesses and so on. Finally, kind of a more wild goal there is to, if someone knows how to write up a linter to detect misuse of metrics, that would be amazing, just so that we never run into, again, a problem of, say, like high cardinality metrics accidentally being introduced, or them being defined like in an incorrect place. That is all I have, so I'll open up to questions.
Great. Thanks, Andrew. Any questions? I know it's afternoon on a Friday.
Andrew, regarding your guidance on individual node alerts, have you explored fault suppression as an alternative instead of deferring those to other systems?
Sorry, what was the suggestion?
Have you looked into suppressing faults? Or just suppressing the noise, looking at ways of filtering or eliminating?
Oh yeah, so right now we do have some measure of aggregation. A big aggregation point is on host group, so at least we then know like a team to ping if all their hosts start failing. So yeah, we ourselves don't have like individual host alerting, because again, like there's always a fire, like that would be absolute madness, but there is like some measure of aggregation, and we still are working on kind of fine-tuning that.
Great, thank you.
I have a really good question, Andrew. For monitoring like all the Spire servers, like what do you guys use? Like what metrics are you watching for to understand that's okay, Spire servers healthy? And another question, like if there is like, let's say network issues, let's say between SPIRE agent and SPIRE server, like which metrics you are looking for to understand this? Thank you.
Sure. So for Spire server health, normally we would look at, say, like the success rate of, like, we don't do fetch JWTs, it's entirely all X509. So just looking at the success rate of fetch X509 kind of is the biggest indicator. And then just the latencies associated with that. And then as far as you said, like triaging if there's a connection problem between agent and server.
Yeah. So
in that case, that would actually come to the second to last slide is like, now we do have kind of a lesson learned of alerting on expecting a certain minimum load from all the agents. Like just having so many agents, you expect at least this many to be talking to you. Of course, if the network outage is very selective and sinister, then we still may not catch that, but it does at least still provide this like baseline knowledge of it. And we do have other alerting still on the TTL left on production identities, or rather we're going to be introducing alerting on that, so that would additionally help. Like if certain agents are having a problem, we'll be alerted to workloads no longer being able to renew their identities.
Gotcha. Thank you.
Sure.